Configure and verify common spanning tree protocols, rapid spanning tree, and multiple spanning tree. Before going into that, let's review the original spanning tree protocol. If you shut down a port, that port will be considered to be in disabled state. If a port is detected to have a configuration or operational problem, that port will be set in broken state. Remember that listening and learning states are transitional and that they only last for forward delay seconds. The max H timer is the death timer for a spanning tree protocol. That means that if a bridge stops receiving BPDUs for max H seconds, that bridge will believe that the root bridge is gone and that bridge will start converging. Remember that the bridge ID is made of a priority and a MAC address. Priorities have a default value. The first thing that the spanning tree protocol does is electing a root bridge, which will be the bridge that has the lowest bridge ID among all the switch domain. Port roles. Any non-root bridge will need a root port, which is the port that has the lowest root path cost. A designated port is a port that is in charge of sending BPDUs down a link that connects to switches. Remember that there are two types of BPDUs: configuration BPDUs that are created by the root bridge every hello time, which is 2 seconds. All non-root bridges receiving configuration BPDUs must forward them downstream. And there is another BPDU that is known as the topology change notification BPDU. Any non-root bridge that detects a direct link failure will generate a topology change notification BPDU and will send it upstream, hoping that the root bridge will receive it. Upon reception, a root bridge will start sending its configuration BPDUs with the TC flag set. Think of local bridge ID as the advertising bridge ID. That means the bridge that is forwarding a BPDU downstream. Convergence for spanning tree is either 30 seconds or 52 seconds. Remember that ports have a port cost that can be either short mode or long mode. For default, Cisco uses the short mode, and the long mode follows that formula. Ports also have a priority, which defaults to 128. A spanning tree protocol uses only one topology, known as the common spanning tree, and it will only have one root bridge, which is known as the common spanning tree root. Remember the spanning tree features like root guard that will place a port in root inconsistent state. If you connect to that port a switch that wants to become the root bridge, port fast will enable a port immediately after port reset, so devices don't have to wait 30 seconds. BPDU guard will place a port in error disabled state if a BPDU is detected on that port. BPDU guard and port fast are usually configured together. BPDU filter will avoid sending BPDUs out of a port. Loop guard will place a port in loop inconsistent state when a port stops receiving BPDUs and erroneously think that there is a convergence going on and tries to transition states. UDLD which means unidirectional link detection, is a technology that helps switches detect individual fiber strand failures. It will build frames using system ID and port ID, send this frame to neighboring switches. The neighbor switch must echo the same frame back. In order to do so, it must be configured with UDLD as well. If a frame is not received back, UDLD can do one of two things. In normal mode, it only sends a warning. In aggressive mode, UDLD will place the port in error disabled state. Cisco has its own technology known as per VLAN spanning tree that will accommodate one spanning tree topology per VLAN. It also uses the extended system ID that takes 12 bits out of the original system priority to store the VLAN number. In order for this to happen, the switch must have the command spanning tree extended system ID, which is configured by default in recent switches, but for all the switches you will have to enter manually. So you have new priority minimum and maximum numbers, and you have to set it in steps of 4096. When you issue the command spanning tree root primary or root secondary, Cisco chooses those default values for the priority, and if you want your per VLAN spanning tree domain of switches interoperate with common spanning tree, you will have to use per VLAN spanning tree plus. The downsides of these technologies consist in that first, PBST plus and PBST generates too many BPDUs, one standard CST BPDU plus one BPDU per VLAN. That means that if you have 100 VLANs, you will be generating 101 BPDUs every 2 seconds. The other downside is that this technology leads to having too many computations, since each VLAN has its own spanning tree topology. If you had 100 VLANs, your switches will have to calculate 100 spanning tree topologies if a link fails. Rapid spanning tree uses 3 port states, discarding, linear, and forwarding. For port roles, it adds the alternate port, which is an alternate path to the root bridge should the path through the root port fails. The alternate port is usually in discarding mode, and the backup port happens when you connect a hub, 2 ports of a hub to your network. One of those ports will be placed in backup port that will be discarding as well. The convergence of rapid spanning tree involves having every pair of switches perform a handshake between them and interchange proposal and agreement messages, so they can reach a conclusion about which ports will be set in discarding or forwarding mode. Each switch will create its own BPDU message. No forwarding of BPDUs exists in rapid spanning tree, and the topology chain notification BPDU is not used very often, but rather normal BPDUs with the TC flag on. These mechanisms will only kick in on point-to-point links. The standard considers 3 types of ports: shared, point-to-point, and edge. If you issue the command show spanning tree, you can come across these port types: shared, P2P edge, P2P, P2P peer when your per VLAN spanning tree plus switch is connecting to an MST region, or type INC if a configuration mismatch, such an access port is connected to a trunk port. It is really difficult to find a Cisco switch that will provide you with a plain, vanilla, normal, rapid spanning tree, but rather you will find Cisco offering you its own version, which is the rapid per VLAN spanning tree plus. So in order to place a switch into rapid per VLAN spanning tree mode, you will have to enter the command spanning tree mode rapid per VLAN spanning tree, and in order to configure the bridge priority, port cost, the port priority, you will have to indicate to which VLAN this configuration belongs to. In order to verify, you will have to use show spanning tree or show spanning tree detail, show spanning tree VLAN, show spanning tree interface. Multiple spanning tree is an evolution of rapid spanning tree. It uses instances. Sets of VLANs can belong to each instance. There is a default instance, which is instance 0. All VLANs belong to instance 0 by default. You have instances 1 to 15 available besides instance 0. Multiple spanning tree addresses the issue of having one topology in the common spanning tree, offering one topology per instance. It also uses less BPDUs than per VLAN spanning tree. You will configure an MST region, which is a group of switches that agree on one configuration set, including the same region name. You must take care when disallowing VLANs in your trunks when using the allowed VLANs commands, because you could cripple your VLANs communications when using MST. An MST region behaves as a single switch to outside switches. If you connect your MST region to PBST Plus, the MST region will simulate being a big PBST Plus switch. At the boundaries, if you issue the command show spanning tree, you will see the port type P2P bound PBST. And you can configure your region to work as a root for all VLANs or non-root for all VLANs for intercommunicating with PBST Plus. You only have those two options. There is no middle ground. At the boundary, MST switches will send PBST Plus BPDUs out, but between the region, the MST switches will only share one BPDU. MST has an internal spanning tree. IST BPDUs will be sent every 2 seconds, and it will be the only BPDU that gets sent. This BPDU will contain information about all the instances. So no matter how many instances you have, you will be only sending one BPDU every 2 seconds. You can have a set of switches having different MST regions. Each region will be its own IST. You can have one IST root per region, and if you connect them all together, you will have common internal spanning tree, and a root for the whole set must be chosen. That will be the syst root. These are the commands. You must enter the command spanning tree mode MST to make a switch use multiple spanning tree. You must enter MST configuration mode in order to set the region name, create your instances and your revision number. If you want to configure your priority or your interface cost and the interface priority, you must indicate to what region you want to apply this configuration to. In order to troubleshoot MST, use the commands show spanning tree MST configuration, show spanning tree MST, or show spanning tree interface. See you in the lab.